chain rule, as you look at it, and it looks like I forgot a parenthesis, but should be another one there. You've seen stuff like this before, right? F of g of x, g of f of x, all that stuff. What were those called? Does anybody actually remember their actual name? Yeah, not Fogg and Goff. In Algebra 2, remember that's that one book, like to use that notation. It's called the composition of functions, meaning two functions have kind of been put together is really what it means. In other words, you put g of x into f of x. It's really what it means. And what they're saying, and this is probably the hardest one to just look at, what they're basically saying is take the derivative of the outside function. You see what I mean by outside function, kind of that one? And then, am I doing anything to g of x at that point? You just write it down. And then you turn around and do what to g of x? Take the derivative. Okay. And so if you look at this first example, it's actually quite simple, but the notation is very strange. You could look at this one as being that f of x was really x to the third, and you can write this down if you want. And g of x is really x squared plus 1. You don't need to do this every time. Once you see this once, we'll be good. All right. And do you agree, at least I hope you do, that if I do that, and I did that completely, oh no, I did it right. This says to put function g of x into function f, correct? So you would take all of this and put it in place of x, and you'd put it right there. Do you agree with that? So wouldn't it become that? Okay. Do you really need to divide these functions up? No. I want you to see what that notation is talking about. The actual use of chain rule is way easier, but you need to see where it's coming from. Yes. Not as easily with this one. Let me think about that as we're going through it, and I'll try and get it to U's and B's for you. It's a little bit harder because of that. But once you see it, I think you're not going to need U's and B's. Once you see it in action, you won't need it. Okay, yes? I got x cubed because I was able to break this up because I saw the cube right there. So I knew basically x squared plus 1 was thrown into x cubed. And replaced, because here's basically x, right? It replaced that x. And like I'm telling you, you don't really have to sit there and divide things up like this. But I want you to see why they're using this notation. Okay? It was one function thrown into another. You might think that that derivative would be very difficult. It's actually not. Okay? So do you agree that the outside function, I have about 5, 6 arrows up here, maybe we can get rid of that, that this outside function was kind of that x to the third, right? If you had x to the third, do you agree you'd put the 3 down in front, you'd leave the x and then make it squared, right? If you had to take the derivative? Well, we're going to kind of do the same thing. We're going to take this 3 times whatever's out front, and what's really understood to be there is a 1 in this case, right? So we're kind of starting to do that part, because that's what you would do if you had x to the third anyways. So the derivative, y prime, of the left side's y prime. So the 3 would go out front, and then you normally would just write down the x and then make it squared, right? But notice, is there any x? It just says f prime, doesn't it? F prime of what? Well, f prime of? So what am I going to put in that parenthesis? Am I going to put an x, or am I going to put an x squared plus 1? Yeah, just write what g of x was, right? So here's how some people say. You kind of start it normal. You just take the 3 times what's out front, just write it down. That's what some people say. But what should I put a third power on it? No, I should make it 2, right? Because do you agree if that was a huge x sitting right there that it would just be 3x squared would be the derivative, right? But that x has kind of been replaced by whatever g of x is. But unfortunately with chain rule we're not quite done. But let's face it, it's way easier than doing definition on this thing. The only thing left I have to do is what up in this little definition that they've got here? The derivative of g. And I kind of look at that as whatever you just threw inside there, isn't it? Isn't that what g of x is? So just take the derivative of the inside, which is 2x. So a recap of really what chain rule says start taking the derivative as if it was power rule, right? 3. But then what you have to do is write down whatever was already on the inside. Then you take it down to power, because that's what you would do if it was power rule, and then take the derivative of the inside. So all we have to do now is just clean it up a little bit. So I'd say what, 6x, and then I wouldn't even multiply that out if I were you. Now how to get 6x? Yeah, the 3 times the 2x. How come I can do that? Because does the 3 or the 2x have a power on it? No, so I can do that. Should I distribute the 6x through that x squared plus 1? No, because that has a power on it, right? If you wanted to distribute, what would you have to do first? Take it to a power, right? So let's not do that. Okay? And let's face it, if we're going to set this equal to something, we'd rather it be in factored form like that than I'll multiply it out, right? Because all you would do is turn around and factor it back out. So let's just leave it there. It's good enough. And let's say I wanted the slope at some x value. Well, you put the x value in. And it's way easier here than if you multiply it all out, you've got more x's. So I would say just leave it right there. That's chain rule. So it might be helpful to decide, well, when is chain rule going to be helpful? Well, whenever you have something in parentheses to a power, do you agree I could have cubed that out and then just taken a normal just power rule on all the terms? Yeah, that would have taken a while, right? Would have taken a long time, really. This is much quicker. And your derivative is a much nicer form than it would have been if you would have done it the other way. Okay? That, very quickly, is chain rule. Again, I just wanted you to see where that f of g of x was coming from. They were looking kind of at 2 different functions here. Okay? Yes? I would say whenever you have something in parentheses to a power, it's a really good time to do that. Because if I were to write this one out, really, can you use product rule on that if there's 3 pieces? No, how many pieces do we normally have with product rule? 2. So product rule is not helpful. Quotient rule is not helpful. You would have to multiply it all out and then take the derivative power rule, but it wouldn't look anything like this. And I think this form is way more helpful than any form I'd get by multiplying out. Okay. Now, that's not only the times you're going to use chain rule, because sometimes you're going to make yourself use chain rule because it's going to be quicker. Okay. For example, remember when long time ago we did just square root of x by the definition? Wasn't much fun, was it? And there really, when it was just the square root of x, we were able to rewrite it as x to the 1/2, right? And then we could just use power rule, right? We're going to do something very similar today. Am I taking the derivative right here? How do you know? Yeah, I didn't take the derivative of the left side. I just rewrote it. How can I rewrite that? So x plus 5, parentheses, very good, to the 1/2 power. Do you agree it's the same thing? Here's that chapter 5 from Algebra 2 coming back to be helpful. Can I just use power rule on that? Unfortunately, I can't, because that was one function thrown inside of another one. If you don't see the 2 functions, it's okay. The one function was the square root of x, and x plus 5 was thrown into it. So there's 2 functions there. It's something in parentheses to a power, right? Well, isn't that when I said we should use chain rule? So let's take the derivative of the left side. So how do we start this chain rule stuff here? What should be the first thing we do? Yeah. Perfect. If you want to write it that way, and you never will have to, by the way, but if you wanted to write the f of x and g of x so you can see the notation, yes, f of x here would be the square root of x, and g of x would be x plus 5 because it got thrown into it. Got thrown into that square root. Okay? Yes? You mean like right here? X to the 4th? Okay, x to the 3rd? All still under the square root? Doesn't matter. Not if the 3 was here. It would be that. Okay? Now, I believe what you're trying to ask, and it's a very good question. I think what Michaela is trying to ask is, what if the original was something else, like a cube root or something? Okay? How do you change that? Yeah, you just make it, because this is all to the 1st, right? So it'd be 1/3 power. Okay? I believe that's what you were trying to say. Yes? Very good. Take that exponent times what is ever out in front, which again is a, is it always going to be a 1? Well, obviously not if I keep mentioning it, right? And so you get a 1/2. Now what? Yeah, just write it down. That's your g of x, right? Now here's where a lot of people do mess up. Negative 1/2. Excellent. Got to go down a power. Very good. Times 1. Why times 1? Derivative of the inside. Very good. And so we just got to kind of clean this up. Do you agree that that 1 right there is on the top and it's fine with being on the top, correct? This 2 is in the denominator and it's fine with that, correct? So far we got a 1 and we got a 2. Well, this 1 over here, well, times 1, well, who really cares? I mean, you can write it if you want, but 1 times 1 is still 1. And now all of this, though, is actually not too happy about with where it's at, right? It would rather be in the denominator. And so you can write it like this if you want. That's fine. But I think it's more helpful if you do that. Or will be more helpful as we go along. All I did is turned it back into a square root. Okay? Either are acceptable and are the same thing. But remember, in calculus, the nice thing is, yeah, leave those things down there. Leave those square roots down there. Because, again, we're going to set this equal to something, right? Or we're going to put something in for x. So why make more x's? Because if you do the conjugate, do you agree more x's are going to find their way into this problem? So why do that to yourself? Now I could give you an x value, and you could be done really quick. For example, maybe an x value of 20 would be quite simple to find the slope, correct? It'd be 1/10. Right? So any questions on that chain rule? Well, it sure made those problems a lot easier. All right. And up until now, the only method we really had for that type was definition. Okay, this one over here, the square root of x, we could do other ways, but not that one. Why don't you go ahead and try one, all on your own. Anybody brave enough to share their answer? Yes. All right. Got it. Okay. All right. Yeah, and you could leave it like this, or if you want to, it's okay because this is a 1 right there. Is it okay to distribute the 2? Yeah, there you can. If it's any other power up here, is it okay to distribute the 2? No, you got to multiply that out first. So it is okay in this one if you wanted to do that. It's completely up to you. Okay. Yep. Mm-hmm. Still fine if you leave it here. So I believe this is the question that someone was referring to earlier. So either they looked at the back of the notes or they were just very clever. You make your distinction. And seeing there's about 15 Michaelas in school right now, it could have been any of them. I would say right now, do not try and just do chain rule as it sits right now. Rewrite it first. Again, there's that chapter 5 algebra 2. Well, I don't want to rewrite it that way. How are we going to go about rewrite? I tried to help you out earlier with how we would rewrite that. Well, it's still x squared plus 2 in here, right? 2/3 power. Very good. Because this number right there is inside, so it goes on the numerator of your exponent, and that number there goes on the denominator. So really, once we get it to that form, it's obviously a very good candidate for chain rule. So y prime equals, what should I write down first? 2/3, very good. Because you're supposed to take that 2/3 times whatever's out front, which is very commonly 1, but not all the time. And x squared plus 2, negative 1/3, very good. Because 2/3 minus 1, you would write it as 3/3, right? That would be the most common, so it would be negative 1/3. Times 2x is correct because it is the derivative of the inside. There are two very common places people get going a little too fast on chain rule and they forget. One of the places is they forget that exponent, and then sometimes they forget to take the derivative of the inside. So take your time and make sure you don't forget those. Now, once again, we probably want to clean this up a little bit. Can anybody look up there and kind of pull the numerator out What would really be left in the numerator? Can you kind of, without sitting there and doing it, can you kind of do it all at once? 2 and 2x, so in other words, if we put it all together, it'd be 4x, right? Because that 2 times that 2x, right? Because there's no power up here on that 2x, right? It's fine with being in the numerator. And so then what's really in the denominator? Well, that 3 there, yep. This 3 is still in the denominator, right? And technically, isn't all of that in the denominator? So the 3, and can you rewrite it all at once? Well, it's a radical, x squared plus 2, and then basically a cube root, right? Is it okay to put this in parentheses and put a 1 in there?
Yeah.
Is it all right to do? Sure. And some people do that just to be safe. Because obviously, what if that was negative 2/3? It would make a big difference, wouldn't it? Right? But negative 1/3, so some people sometimes forget about it. So there you go. There's your derivative. The question there was, is it okay if you just kind of move it to the bottom and leave it as the 1/3? It is okay, but again, with what we're going to be using this for, sometimes it's better to have the radical there. Yeah. Because we are going to start setting this equal to stuff and start substituting stuff in, and I think it's easier to see the cube root when you do that. So any questions? Yes? You mean from the 2x? Yes, because it is all multiplied together. And as of right now, that 2x has an exponent of 1, and so it would be on the numerator, because that's where it was. Mm-hmm. Anything? I believe this one is relatively similar to that number 2 that you had the other day. Very similar. Now, many of you, we had to do it by the definition, right? And many of you, I think, checked it by doing quotient rule, and there's nothing wrong with that. You checked it to make sure you had it right. There is a quicker way when your numerator, because let's face it, when you did quotient rule and you did part of it, didn't part of quotient rule go away because the derivative of the top is 0? Right? Whenever that's going to happen, and that's whenever the numerator is a constant, right? Whenever you have that, you can rewrite this. How can I rewrite this? This is going to make you think a little bit. So that I can use chain rule. And this only works, this little part only really works when there's a constant on the top. Yes? Which 2? Yeah, this 2 right here, basically just make it negative, or in other words, make the 2t plus minus 3, make it unhappy. So the negative 7's already on the top, right? And so what we're going to do is we're going to pull this up there and make it unhappy, but when we make it unhappy, negative 2 power, correct? Does that appear to be the setup for chain rule? Yeah, it does. Now, I think this is the first time that there's actually been something out front, though, other than 1, but that's fine. Again, it works very well when there's a constant up there. So now let's go ahead. Well, we took the derivative of this side. I love that side. That's always easy. And so now we take that negative 2 times that negative 7. We get a 14. Write down the 2t minus 3. I heard it quite a few times. Just wanted to make sure. It would be negative 3 power. Very good. Because it was negative 2. You subtract 1. It is negative 3. And then some people get really excited because they got that right and forget to do something. Derivative of the inside, and so they forget the 2. Okay. And just a little bit of cleaning up. Again, it'll be very helpful if you can start pulling kind of things out in your mind. What's my numerator? 28, very good. And my denominator, 2t minus 3 to the 3rd. Yeah, so there's no radical in this one because there was no fraction in the exponent. There it is. And again, do not cube that out, because all you're going to do is turn around and try and factor it. So don't do that. Any questions so far about chain rule? Well, good, because this one's interesting. Can you distribute that x squared that's on the outside through the radical? No, you can't. You could rewrite it. I like that idea. But if you rewrite it, do you agree it is still remember way back when we did product rule, I told you that on some of them product rule is kind of a waste of time because you could have just FOILed it out and been done with it. Well, here's one of those instances where knowing product rule and knowing it very well is going to come in handy. Because there are two functions, this one and that one, being multiplied. So do you see how this one is different from this one? There's just a constant out front. Could you have done product rule on this problem? Yes, you could have. But again, part of product rule would have gone away because the derivative of -7 is 0. Okay, so it's a slight waste of your time to do product rule on that. Here, there's no way around it because it's an actual function. Okay, it's not just a number. And so we will have to use product rule, and I think you like to use u and v. Is that correct when you do product rule? Now, product rule, what's in the middle of all that? A plus, minus, it's a plus, right? So does it really matter the order? Not really. So here we go. Is everybody prepared? So I normally do it right down the first one. That's normally what I do, and you can do it the other way. It's fine. So write down the first function, which is x squared. Agreed? Times the derivative of the second. But if that second function, that letter v there, was the only thing I gave you, how would you take the derivative of that? By the chain rule, right? So this is basically chain rule inside of product rule. Okay? So let's just go ahead and say this is the only thing that I gave you and take the derivative. Well, how would you do it? It'd be a 1/2, right? Because you take the 1/2 times just the 1 that's out front there. Ever see the difference there? And write it down. Now what for chain rule? Why -1/2? Got to go down a full power. Very good. And my u's and v's are going to get in the way, aren't they? U, v. There we go. So the -1/2, and very easy to forget this next little maneuver. Yep, derivative of the inside, which is -2x. Well, isn't that fun? Yeah, there's still more. Very good. I was going to see if you'd let me go on. There's still more. What should I put next? What should be the very next thing I write down? A plus. Yeah, because I only did half of product rule. Now I got to write down the second one. Well, at least this derivative is going to be easier, right? And take it times the derivative of the first one, which is 2x. Now, is this the one where it's all over something squared? Oh, which one's that again? That's quotient rule. But just think of how much fun the definition would be on this one. Putting x plus delta x in for all those x's and subtracting that, it'd be spectacular. Oh, here's always the point where I have to make a decision as to whether you can handle this nice little bit of algebra, because it happens a lot in this type. Maybe I'll do this one the long way, and then I'll come back and show you the other possible way of finishing this one at this point. So what we should do, this is kind of a little bit longer method, but I think it's the one most people understand better. We got to clean this up. I don't know about you, but I don't want to set that equal to something. And I really don't want to substitute x's in all those places either. So is that technically the derivative? Well, yeah, it's just in a just horrible mess. And so I would suggest that you look at it this way. There's two distinct kind of sides to this thing. Only deal with that left-hand side and let's clean it up. And do you agree basically all of that's multiplied together on that left portion there? So here's where being able to pull stuff out of there is going to save you a ton of time. Do you agree this one's going to end up as a fraction of some kind? Because all of this really wants to go down, and it's a square root, right? Do you agree that's what that turns into, what I just put that black, I don't know, kind of circle around? Is that the only thing that ends up on the bottom? Well, technically it does, but you can put the 2 down there if you want, but I kind of look at this 2 right there and that 2 right there as canceling personally, but would you prefer that I put the 2 on the bottom and then cancel later? Put it down and cancel? All right, so this 2 goes down there then, and that'd be this one right here, okay? So I'm going to get rid of my little black arrows here. So to agree then on the numerator, I've got this x squared times that 1 times that. So it's a negative, right? Negative what? 2x to the third. So that's that portion. Can I cancel the 2's now? Okay. All right. So those 2 canceled. And so we'll make it a little smaller here. There we go. There we go. So it's negative x to the third over the square root of 1 minus x squared. Okay, plus. What are we going to do there? Is there anything we can do? Not really. Now, technically, there's nothing wrong with that, right? I mean, I could substitute x values in there if I had to. Agreed? But setting that equal to something, probably not going to be a whole lot of fun, is it? Well, we've got 2 pieces. One is a fraction, one is not. Yes? Yeah, we need a common denominator here. Unfortunately, what is the denominator of the first part is 1 minus x squared square root, right? This one has a much better denominator at this time. It's a 1. Well, that's spectacular, but it doesn't have this. And so we do have to kind of multiply by a funny form of 1 here, right? And so over here, we have to get on the bottom that, right? That's what I need on the bottom. But you can't just go around just multiplying bottoms by that. You can multiply by 1, though, to any term you want at any time. And so I'm just going to multiply it by 1 then. It's a horrific form of 1, but it's still 1. Oh, yes. Okay. Are we in agreement that we will end up with a common denominator? Excellent. And it will be that? Okay. Well, we got a negative x to the third on the top. I know that much because it's already on the top with that as a denominator. The real question is what happens with all of that? Why do they cancel? Because this, you agree I'm taking some square root times the exact same square root? So it's really 1 minus x squared squared square root. So it calcifies, right? So in other words, just that part, and I'll color code it for you. There's a 2x there, and that basically becomes that, right? For those of you that are struggling with that, if I took the square root of 5 times the square root of 5, I get 5, right? Because it becomes the square root of 5 squared, cancels. Okay. So now we're almost there. Remember, this is the longer version, but probably the easier for most to understand. We got negative x to the third plus, let's distribute that bad boy there. Now, why would I distribute now and not other times? Well, because now there's possibility of something canceling, right? And what do we got there? Plus 2x minus 2x to the third. Does something cancel? Wow, that's the worst 1 minus something I've ever seen. Wish these smartboards were bigger. All right. So I'm going to have to cheat a little bit, and I'm going to combine those by some erasing. All right. And so there's a negative x to the third and a positive 2x and a negative 2x to the third. Agreed? Which will all combine being a 2x and a negative 3x to the third, correct? So I'm going to have to cheat a little bit. There's your derivative. You could factor an x out of the top if you felt like it. And just remember, that's the shortcut. Because if we put x plus delta x in there, we'd still be working. Yes? This one here? This x to the third came from me taking that x squared times that negative 2x. And then it was negative 2x to the third for about a second, but then there was a 2 down here as well, and so I canceled. Okay, that's where that particular one came from. And then this one came from the multiplication of right here. 2x times negative x squared. Yep. Mm-hmm. Yes. Uh-huh. Yes, that 2 that was here for a very short period of time came from there, and the 2 that was here came from right there, but then they canceled. Yep. Yep. Any questions? All right. We'll revisit that in a second.